In this video, I'm going to cover the Geometry End of Course Assessment Practice Test questions. And this is part one because I pulled these questions from the Florida Virtual School Geometry End of Course Practice Test. And so in this video, I'm covering the first 20 questions from that practice test. So this is part one. So let's get started. The first thing we're going to review before we get started is parallel lines cut by transversals. And so we have our transversal here because it intersects those two lines, and then we have the parallel lines, and this is denoted by the parallel line markings here. We're looking at corresponding angles. These two or one pair of corresponding angles are in red, meaning they're in the same position of the transversal and the parallel lines. So as you can see, those two angles in red are on the upper left. So they're above the parallel line right here, and they're on the left side of the transversal. So same position, they correspond, they are equal, they have equal measure. Next you have alternate exterior. So think exterior, they're on the outside of the parallel lines. So in orange, so they're on the outside of the parallel lines, and they're on opposite sides of the transversal here. So alternate exterior, outside of the parallel lines, opposite sides of the transversal, and those have equal measure as well. Next you have vertical angles in yellow. I like to call them opposite equal angles. Kind of a, I'm saying the opposite thing, but I say opposite because they're across from each other and they are congruent. And so vertical angles are in yellow, and they form like a T shape or maybe an X. So opposite equal angles. Next you have same side interior angles. So just like, same side interior angles are in green here. They're on the same side of the transversal, and they're on the inside of the parallel lines, and they equal 180. So these two angles together equal 180 degrees. Next you have alternate interior angles, just like alternate exterior, except they're on the inside. So they're on the inside of the parallel lines, but they're on opposite sides of the transversal, and they are also equal. And then next you have same side exterior angles, and so they are in purple, they are on the same side of the transversal, but they are on the outside of the parallel lines. So that's just a quick overview of parallel lines cut by transversals. If you need to, pause the video if you need to just review it a little bit more. Let's take a look at number one. It says, in the figure below, what is the measure of angle BKM? So angle BKM is right here. Let's locate the angle first, and let's analyze this figure here. Line segments A, B, and DE are parallel, and I know that because I have these parallel line marks here. And HI would be the transversal, so they intersect those two lines. So that would make angle BKM and angle KML right here. Hopefully you can see my arrow there. And angle KML, same side interior. And if you remember, same side interior angles are equal to 180 degrees. So that will make these two angles equal to 180 degrees. So since I know that angle KML is 32, I could simply subtract 180 minus 32 to get 148 degrees. So that will make angle BKM 148 degrees. And there's my answer. Now let's take a look at number two. It says, in the figure below, what is the measure of angle MKJ? So angle MKJ is right here. And we have this 58 degree angle, which is angle KML. Those are same side interior. So again, they equal 180. So I could simply subtract 180 minus 58, and that is equal to 122, which is the So if you notice in both numbers 1 and 2, you were given extra information that you don't need. We don't have to use this 98-degree angle here. So just because you're given extra numbers or numbers or information does not necessarily mean that you have to use it. So keep that in mind when you're taking your test. Number 3 says, what is the most accurate name for the triangle below? And if we notice here, we have two equal sides, and so that has to be an isosceles triangle. So I can eliminate A and D. A scalene triangle has no right sides, and so I'm left with B and C. I notice here that I have a right angle, so that would be, so I can eliminate choice B, so that would be, or this triangle would be a right isosceles. Let's take a look at number 4. What type of triangle is shown below? So if we look at A, it says equiangular. That means that all angles are equal, so that would not work. Right isosceles. Remember, with an isosceles triangle, you have to have two congruent sides, and you have to have a right angle, so we don't have either there. Next, we have acute scalene. So acute means that all of your angles would be acute and that no sides would be congruent. 110, that is obtuse angle, so that will not work. The only thing that is left is D, which is obtuse scalene, and we have this obtuse angle here, and we don't have any congruent sides. Number 5 says PR has an endpoint of 25, -5, and a midpoint of 18, -1. What is the x-coordinate of the other endpoint? And so I notice here that I'm given the midpoint and I'm given an endpoint. So I could actually use the midpoint formula to find my other endpoint. So remember, the midpoint formula here is x1 plus x2 divided by 2. And y1 plus y2 divided by 2. Remember, your midpoint is going to be an ordered pair. So you're basically adding your x values, dividing by 2, adding your y values, dividing by 2. But I want to find my other endpoint. And so I'm going to, and I actually just want to find the x-coordinate, but for the sake of reviewing, I'm going to actually find both. And so I want to find x2, which is what the problem is asking, but I'm also going to find y2, or my other y value. And so what I could do, I could set up an equation. Midpoint equals x1 plus the variable x divided by 2. So my midpoint is 18. So I'm going to take the x value from my midpoint, because remember, every ordered pair has an x and a y. So the x value for my midpoint is 18. So I'm going to plug it in for m. So 18 is equal to x1 plus x2. So I'm going to use the x value from my endpoint here as my x1. And I'm going to find my other x value. I'm not going to put x2 because that, or x sub 2, because that just makes the problem look a little more complicated. And I just really want that unknown variable there. And so I could just solve this problem to find x. And so using your algebra skills, I want to solve for x. Let's multiply both sides by 2. 2 times 18 is 36. I'm left with 25 equals 25 plus x, not equals. So plus x. And I'm left with the one-step equation. I'm just subtracting 25 from both sides. 36 minus 25 is 11. So the x value is 11. And I have found my answer here, 11. I'm just going to find the y value just because we're reviewing here. So the same thing I'm going to use if I want to find my y value. My midpoint is, for my y value, is -1. So that has to go on the left-hand side there. It has replaced the midpoint. So -1 is equal to, and I'm going to use the y value from my endpoint, and that's going to be -5 plus y divided by 2. And again, I'm not putting the little sub 2 and sub 1 because I think it makes the problem look a little more complicated than what it is. And solving, multiply both sides by 2. 2 times 1 is -2. -5 plus y. Again, one-step equation. Since that is a -5, I'm going to add 5 to both sides. -2 plus 5 is 3. So my y value is 3, and so my my endpoint will actually be 11, 3. And again, it just asked me for the x-coordinate, but I found both. And you could actually check your answer. Well, how could you check it? Well, since you could plug it back into the midpoint formula. Add your x values of your endpoint, divide by 2, you should get your midpoint. If you add 25 and 11, right, you get 36. 36 divided by 2 is 18, and it checks out. It gives you the x value midpoint. And let's check our y value. If I add -5 and 3, I get -2. -2 divided by 2 is -1. That gives me my midpoint. So I did a little extra work because again, we're reviewing here. So this is how you find the other endpoint if you're given a midpoint and an endpoint. Number 6 says TV has endpoints, not actual TV, but TV has endpoints 210, and so the line segment TV has endpoints 210 and 18, -18. What is the approximate length of the segment? Anytime you're given 2 points and you're asked to find the length of a segment, you can always use the distance formula. So you may not have a problem that says find a distance. But anytime you're given 2 endpoints and you want to find the length, you can always use the distance formula. So we have the distance formula here. And then I'm just going to label my ordered pairs, x1, y1, x2, y2, and plug it in. So plugging that in, x2 minus x1 is 18 minus 2 squared, plus y2 minus y1, -18 minus 10 squared, and then I'm just going to simplify. 18 minus 2 is 16, that's 16 squared. -18 minus 10 is going to be a -28. So please pay attention to your negatives. I would hate for you to understand how to do the problem, but then just mess up because you didn't add your negatives correctly. So make sure you're paying attention to your basic integer rules there. Next, simplifying even more, 16 squared is 256. -28 squared is 784. Combining these two numbers, I get 1040. Taking the square root of that, that gives me approximately 32.25. So my answer choice would be B. So before we move on to our next few questions, I want to just quickly review points of concurrency. And remember, points of concurrency are where 3 or more lines intersect. And in this case, we're looking at the centers of triangles. And so you have your circumcenter, incenter, centroid, and orthocenter. So just a quick review. We describe the points of concurrency by what they are intersected, by what lines are created to intersect. That they intersect. So circumcenter is created by perpendicular bisectors, and as you can see here, we know that these are perpendicular bisectors because we have these right angles here, and they are bisectors because we have these congruence marks. So they're cutting each side in half equally, and they're cutting it in half at a right angle. So circumcenter created by perpendicular bisectors. Next you have incenter. They're created by angle bisectors, and if you notice here, we have these angles, and we know that they are bisected because we have the congruence marks for each of these angles, meaning they are cut in half equally. So incenter created by angle bisectors. Next you have centroid. They are created by medians, and remember, medians go from a vertex to the opposite side, and they cut the other side in half equally. So we can see here that these two are congruent, and so that will make BZ a median, AY, because again it goes from the vertex to another side, cuts it in half equally. So centroid created by medians. And last, we have altitudes, not altitudes, the orthocenter, and that is created by altitudes. And an altitude, similar to a median, but it does not cut the other side in half equally. It goes from a vertex, but on the opposite side, it creates a right angle, so it is perpendicular to the opposite side. So if you think altitude, you think about the height. And so we have 3 altitudes here, so it goes from the vertex to the opposite side and creates a right angle. So just a quick review of centers of triangles, and so let's try the next 2 problems. Number 7 says, look at the triangle ABC. O is a centroid. So now remember, a centroid is a point of intersection for the medians. So remember, median bisects the side of a triangle, so it goes from a vertex to the opposite side, and it cuts it in half equally. So since O is the centroid and lies on segment EB, segment EB bisects side AC, and so right here, these two, so AE and EC would be congruent, and so if we look down here, BO and OE are congruent. No. DF and AE are congruent. No. CD and BE are congruent. Nope. Segments AE and EC are congruent, which is what we found right here. So the answer to this question would be D. Let's take a look at number 8. It says point O is the circumcenter of the triangle ABC shown below. Which segment passes through point O for all lengths of the triangle? For all lengths of the sides of the triangle. Let me read the question carefully or correctly. So this is point O. So let's analyze this figure. Remember, a circumcenter is created by perpendicular bisectors. So segments EO and FO are perpendicular bisectors, and we know that because we have these congruence marks here, and we have these right angles, meaning that they are perpendicular lines there. And it intersects at point O, which is the circumcenter right here. And I kind of already circled it, but I'll circle it again right here. And so the only possible segments that will meet all conditions of the question is a perpendicular bisector of side AB. And so, what do you know? B, we have that right here, perpendicular bisector of side AB. Number 9 says Rebecca is designing a backpack and needs to determine the length of the adjustable strap that connects the shoulder strap to the backpack. The height of the backpack is 19.5 inches and the shoulder strap is 12 inches. We're asked what is not a possible length for the connecting adjustable strap. Now, the triangle inequality theorem tells us that the sum of the lengths of any 2 sides of a triangle, it has to be greater than the remaining side. So if we add any 2 sides of the triangle, their sum has to be greater than that third side. And so we can actually find the range for what the third side should be by simply adding and subtracting the 2 sides to get the range. And so I'm going to add 19.5 plus 12. And that gives me 31.5. Then I'm going to subtract 19.5 minus 12. And I'm just getting a range. That gives me 7.5. And so the range of that third side will have to be between 7.5, and I'm just going to use X, to 31.5. So it has to be in between these 2 numbers. And the only one that does not fit is A. So the rest of these could be side lengths, but A, which is 7 inches, cannot because it is less than 7.5. It is not in that range. Number 10 says Ruth Ann is buying a home and the plot of land is triangular. She would like to have a long property line along the street. The given angle M is opposite the road of the plot of land. Alright, so here's angle M. The following are angle measures of angle M for the 4 different properties that Ruth Ann may choose from. And we're given 65, 89, plot C is 68, and 103. So we're asked, which property has the longest property line on the street? And so if you recall the Hinge theorem, it tells us that the side of the triangle across from the largest angle will be the longest side. And so also you could use logic and say that the smallest side will be opposite the smallest angle, and the middle angle will be opposite that middle side length. And so in this case, we're looking for the longest side, and so that would have to be 103, and so it would be plot D, which would give us the longest side opposite that angle. All right, so now we're just past that halfway point. We're on number 11, well, the halfway point for part 1. It says the figure below shows the length of side DC equal to 120 units and the length of side DB is equal to 160 units. What is the length of segment AC? So we're looking at the length of this segment right here. So now we have some congruence marks, and we can actually use our side angle side theorems. And so what we notice here is that we have angle or triangle DBC and triangle ACB. So these two triangles here. Hopefully I'm not confusing you with all my markings. So I'm just showing you that we have two separate triangles here. So I'm actually just going to erase all of this. So now you see that we have two separate triangles here. And so we see that side DC and AB are congruent, right? And we could use reflexive property. They share this side, so they have two congruent sides here, right? And they also have congruent angle measures right here, right? DCB and ABC. So two separate triangles. So we have a congruent side, angle, and another congruent side. We have a congruent side, angle, and another congruent side, right? So these triangles are congruent. And so according to CPCTC, corresponding parts of congruent triangles are congruent. And so since these triangles are congruent, side DB is 160 units. That will make side AC also 160 units. And so my answer would be B. So number 12 says triangle MNO and triangle PQR are similar. What is the length in units of segment NO? So since we know that these two triangles are similar, that means that their sides are proportional. So ON is right here. It is opposite that 75-degree angle. So the corresponding side would be side RQ, which is opposite the 75-degree angle. So I could set up one fraction here to set up my proportion to solve. So I could say, I'm going to call ON X, my unknown. So I could say X over 33 is equal to, and then if I go back to my first triangle here, side 28, 28 corresponds to the middle angle because 60 is in between 45 and 75. So my 60-degree angle over here is across from the side length of 42. So I just set up my proportion there and cross multiply and solve. So x times 42 is 42x. 28 times 33 is 924. One step equation, dividing both sides by 42. So it's using some algebra skills here. And that gives me, so 24 divided by 42 is 22. So my answer would be C. I also could have set it up differently. So with proportions, as long as your sides are corresponding, so I could have set it up as 28 over 42. And x over 33. So the sides could be flipped, and I could have set it up differently where my fractions are within the same triangle. Again, as long as your sides are corresponding, you're going to get the same answer. Number 13 It says Ben has a toy lightsaber. He wants to construct one proportionally smaller than his. So important word here, proportionally. The light on his is 33 inches and the handle is 9 inches. If the light on the smaller version is 11 inches long, how long should the handle be? So we're looking for this handle right here. So I could just set up a proportion, 33 over 9. So that is my larger lightsaber. And in proportion to 11 over x. And so again, both my sabers here, 33 and 11 has to be in the same position, as well as 9 and x, because they're both handles there. So, and then I just solved this. Cross multiply, 33 times x is 33x, 11 times 9 is 99. One step equation, 99 divided by 33 is 3. That is my answer. Let's take a look at number 14. It says in the triangle below, what is the approximate value of x? And so x is right here. And so since segment DE is parallel to AC, and I know they are parallel because I have these markings here, the portions of the sides of triangle BDE, which is this small triangle here, and triangle ABC, which is the large triangle, they are proportional. So I could set up a proportion to determine the side length of BE, which is x. And so I could say that BD over BA, so right here, is equal to, I should have put my equal sign in the middle there, right? Is equal to BE over BC. So I'm setting up proportions from the smaller triangles and the larger triangles. So BD again is my small and BA is my larger triangle. So at the top, BE again small, so make sure same position, and then BC, which is from that larger triangle. So let's fill in our numbers here. So side BD, which is the small triangle, is 4. And BA, and if you notice BA, we have 18 and 4, right? So BA is here. So the entire length of this side would be 18 plus 4, so that would have to be 22. All right. And then BE, we don't know that, so we can call it X. And BC. So BC, again, that larger triangle there. We don't know the length yet, but we do know that X plus 22 will give us the length of BC. So on the other side, we had 4 and 18, so that's how we got to 22. But for side BC, we don't know what X is, and so we just had to write an expression of X plus 22. So now to solve it, we're going to cross multiply, so algebra skills. So 4 times X plus 22, and I'm using parentheses because I have to use the distributive property because I have to multiply 4 by both the X and the 22. And then I have 22 times X, which is 22X. All right, distributive property, 4X plus 88 is equal to 22X. Solving for X, since I have 22X on the other side, I'm subtracting 4X. That leaves me with 88. 22 minus 4X will give me 18X. So if you're noticing here, we use a lot of algebra in geometry. So 88 divided by 18 is approximately 4.9. All right, and that would be C. Number 15, it says, look at the figure shown below. What is the length of segment AB to the nearest tenth of a meter? So segment AB is right here. So what I do notice about one of these triangles is that it is a 30, 60, 90 degree triangle, and that is a special right triangle. So let's just do a quick review of special right triangles. Although we're just working with the 30, 60, 90, I'm going to do a quick review of both here. So with the 30, 60, 90, the shorter side is opposite the 30 degree angle, and that is just x, so we can call it S. Everything is in reference to that shorter side. And so the hypotenuse is twice the shorter side. And I know that's the hypotenuse because it is opposite the right angle. And then my longer side, or my longer leg, would be, and I know it's the longer leg because it is opposite the 60 degree angle, it is the square root of 3 times the shorter leg. So everything is in reference to the shorter leg. Quick review of 45, 45, 90. The two legs would be congruent because they're opposite the same degree angle. And the hypotenuse is the square root of 2 times that shorter leg. So as an example, if my hypotenuse was 7 square root of 2, then my legs, because they would be congruent, would be just 7. So a quick review of both. But since we're working with the 30, 60, 90, let's use that one here. So we're given the hypotenuse of this triangle. It is 14. And since I'm given a hypotenuse, I could find my shorter leg, which is AD, because it is opposite this right angle. All right, so that is my shorter leg. And looking at my figure here, the hypotenuse is twice the shorter leg, and so that will make the shorter leg half of the hypotenuse, right? So half of 14 is 7. So the length of AD is 7 because hypotenuse will be twice that shorter leg. Now I found the portion of AB, so I have to find DB. I'm not given really that much information for this other triangle here, but I could find the length of this side, of side DC. So side DC is actually the longer leg of this triangle, and the longer leg is the square root of 3 times the shorter leg. So the longer leg of this triangle would be 7 square root of 3. That's a 7 there. So 7 square root of 3. Now I have two sides of this triangle right here. All right, just want to show you. So I'm going to erase it. All right, so I could use the Pythagorean theorem to find the length of that third side. Remember, you can always use the Pythagorean theorem if you're given a right triangle and you're given two side lengths. You can always find that third side by using the Pythagorean theorem if you have a right triangle. So this is the Pythagorean theorem. Of course, A and B are your legs, and C is the hypotenuse, which is opposite the right angle. So one of my legs is 7 square root of 3, or 7 times the square root of 3. And my other leg is DB, which is what I want to find here. I'm just going to call it X. All right, so I don't have to plug in two letters there. So X squared, which is what I'm looking for. C is the hypotenuse. The hypotenuse of this triangle is 13. So that would be 13 squared. Now simplifying, 7 squared is 49. The square root of 3 squared is just 3. Because remember, if you raise anything to the second power that is already the square root, it's just going to be that number, because this is really like raising 3 to the 1/2 power. So it gets rid of that radical there. So that is 49 times 3. I'm leaving that in parentheses for now so I can simplify that. 13 squared is 169. And 49 times the square root of times 3, again, because 7 squared is 49. And the square root of 3 raised to the second power is just 3. It just gets rid of that radical. So 49 times 3 is 147. Now I can subtract that from both sides, the 147. That gives me x squared is equal to 169 minus 147. I think that is 22, but let me just make sure. It is. And taking the square root. Square root of 22 is approximately, I'm going to round to the nearest tenth, 4.7. I get like 4.690, but I'm going to just round it to 4.7. And so the length of DB is 4.7, which is here. So to find AB, I just simply add 7 plus 4.7. So AB is equal to 7 plus 4.7. That is equal to 11.7. Wow, that problem took me almost 6 minutes to complete. So lets you know that some of the questions on your test may take a bit longer, but that is okay, as long as you get it correct. So let's move on to number 16. Number 16, it says, what is the length of side AD? Again, we have that 30, 60, 90 degree triangle here. So AD is here. All right, and so we have a length of 12. So let's analyze this shape, or these two triangles here. So what I notice, I have a 90 degree angle right here. So that would mean that in triangle DCB, that this little piece here would have to be 60, not 30. It would have to be 60, because remember, triangles have to add up. Their angles have to be 180. So if this is 90, this little piece would have to be 60. So this piece here would have to be 30, and I know that because I have this right angle right here. So they would have to add up to 90. So this little piece here would have to be 30. And I'm noticing, again, okay, I'm going to get a 30, 60, 90 degree triangle, because right here, this would have to be 90 degrees, because that's a linear pair. And so if this little piece is 30, if this is 90, that will make angle A 60 degrees. And so now I could use that knowledge to find AD. So I have 12 here. 12 is, so in reference to the smaller triangle ADB, that smaller triangle, that the side AB would be the hypotenuse, right? Because it is opposite the right angle. So in this small triangle here, I'm just looking at this triangle. If that 12 is the hypotenuse, that would make, I could find AD, because AD would be the shorter side. And I know that that is the shorter side because I have this 30 degree angle, and opposite that 30 degree angle would be the shortest side. So my hypotenuse is 12. That would make AD 6, because it would be half of my hypotenuse. So I have found the length of side AD. All right, so let's look at number 17. We want to look at the figure, and it says, what is the distance in meters between point B and C? So I know I'm going to have to find the length of side BC, so I'm just going to label it X, because I know I'm going to have to set up some type of equation to find it. And what I notice here is that I have an angle, which is 35 degrees, and I have a side length, which is 200. Anytime you're given an angle and a side, know that you can always use a trig function to find the other side. All right. Also, if you're given two sides and you want to find an angle, you can always use inverse trig. So in this case, I'm given an angle and a side. So just going to do a quick review of trig functions. So katoa. So remember, so is sine, which is opposite over hypotenuse. Everything is in reference to the angle that you're looking at, that you're using. So here we have angle theta. So right here. So sine would be opposite over hypotenuse of the angle. Cosine would be adjacent over hypotenuse. And you may look at this if you don't quite remember and say that the hypotenuse is also adjacent, right? So which one do I use? Well, just remember that hypotenuse takes precedence over the adjacency. So adjacent and hypotenuse would never be the same. We will always use the side opposite the right angle as the hypotenuse. All right, so last we have the tangent, opposite over adjacent. So opposite side here over adjacent. So everything is in reference to that angle. All right, so back to our figure here. So I'm given a 35 degree angle, and I want to find side BC, which is the hypotenuse. And I know that that is the hypotenuse because it is opposite the right angle. And you probably caught that I was about to put adjacent, but hypotenuse takes precedence, and side BA would be the adjacent side. Remember, adjacent is next to. That's what that means. And so I have adjacent and hypotenuse. What trig function uses that? Of course, cosine. So the way I would solve it, I know I have two down here that have cosine. So I could eliminate B and D. So cosine of my angle of 35 is equal to adjacent. So the adjacent side is the 200 meters over hypotenuse. So in order to solve, I'm going to use a different color. I have to multiply both sides by x first because the x is being divided. So that is x times cosine of 35 is equal to, this cancels, is equal to 200. Now to solve for x, I need to divide both sides by cosine of 35. Cancels out. I'm left for x is equal to 200 divided by cosine of 35. And if you were asked to find an answer, you would just plug this in your calculator, 200, hit your division key. Some calculators you can put the trig function and then the angle and hit equals, or in some calculators you would have to put in the angle first and then hit your trig function. So just depending on what calculator you have, which is that is how you would plug it in. So I actually have what I need here for C, 200 divided by cosine of 35. So my answer for this problem is C. Number 18 says, look at the ramp PQ. So my ramp here, PQ, is 2,500 meters. We want to find the height of ramp PR in meters. So PR is here. I'm going to call it X. And again, we have a side and we have an angle, so I can use trig. So in reference to this angle, I have the opposite side and I have the hypotenuse. That is the trig function sine. So I could set this up. Sine of 23 degrees is equal to opposite, which is x. So the x will have to be at the top because it has to be in that order. So x is the opposite side, opposite is at the top. So opposite over hypotenuse. Hypotenuse is 2,500. So now I just want to solve this. So since the 2,500 is being divided in this case, I multiply both sides by 2,500. Cancels out over here. That leaves me with 2,500 times sine of 23 equals x. So I could just put that in my calculator. So now depending on what calculator you have, you will plug it in differently. So with the TI-30X, you could do 23, hit your sine key and hit equals, then multiply that by 2,500, and you will get 976.8. If you have another calculator, I have a Casio also. You could just also put sine of 23, hit enter, and then multiply that by 2,500. So make sure you work this problem out with the calculator you have so you can know how to use it. But I get 976.8 for this side length here. So before we do our last two problems, I'm just going to do a quick review of quadrilaterals. I'm not going to read everything on the slide. If you want to pause the video and just take a few notes from this, please feel free to do that. But just a quick overview with these quadrilaterals here. A parallelogram includes a rhombus, a rectangle, and a square. For a parallelogram, the opposite sides are parallel and congruent. Opposite angles are congruent. Consecutive angles, which are angles on the same side, are supplementary, meaning they equal 180. And the diagonals bisect each other, meaning they cut each other in half. Okay. A rhombus, rectangle, and square also has the same conditions as a parallelogram, but it also adds these extra conditions. So a rhombus will have all of these, right? But then it will also have 4 congruent sides, diagonals are perpendicular, and so forth. Rectangle, same thing. It will have all of the conditions for a parallelogram. And then with these two conditions here, a square will have conditions of all of them. It will have conditions for both the rectangle and the rhombus and the parallelogram. But in addition to that, it has 4 congruent sides. A trapezoid over here only has one pair of one pair of opposite sides that are parallel. All right. A kite, 2 pair of consecutive congruent sides. So right here and here. And isosceles trapezoid, non-parallel sides are congruent. So these two sides are parallel. These are my non-parallel sides here. They are congruent. So just a brief overview. Again, if you want to pause the video and write down all of these notes, you can. But I'm going to use these properties to answer the next few questions. Number 19 says look at the chart. And so we have the quadrilateral, a square, and a rectangle. And all interior angles are equal. So yes and yes for both the square and the rectangle. And we want to know, it says which title best represents X. So we want to know what should we put here. So if we look at A, it says has all equal sides. And squares have all equal sides, but rectangles do not. So yes, that will fit a square, but no, it will not fit a rectangle. So actually, we have found our answer. But just keep going, just to do a little more review here. So the answer to this question would be A. But if we look at B, it says has all angles equal to 180. Not possible in a quadrilateral. All angles are always equal to 360 degrees. So 180 is a triangle, right? C has adjacent sides unequal in length. Remember, adjacent means next to. A rectangle has unequal adjacent sides, but a square does not. So that would be actually the reverse up here, so that will not work. And D has sum of all interior angles equal to 360. All angles in quadrilaterals equals 360, so that would be true for both. But we have no up here for a rectangle, so that would not work. So of course A would be our answer. Alright, so we have reached the last question for part 1, finally. Number 20, it says, look at the shapes shown below. Which statement is true? A says shapes 1 and 3 are kites if their diagonals intersect at a right angle. So remember, property of a kite, the diagonals of a kite are perpendicular to one another, meaning they intersect at a right angle, so that is true. So once again, A is our answer here. But again, just going to keep going for a review. B, it says 2 and 4 are trapezoids if they have at least 2 pair of parallel sides. Remember, a trapezoid only has 1 pair of parallel sides, so that is false. C, it says all these shapes are parallelograms if they have 4 sides. If they have 4 sides and 1 pair of parallel sides. False, a parallelogram must have 2 pair of parallel sides. And D says shapes 1, 2, and 3 are parallelograms if they have 2 pairs of sides of the same length. This is false as well. Only 2 types of parallelograms, which are squares and rhombuses, or rhombi, or a square and a rhombus, have all congruent sides. And so A would be our true statement. The diagonals of a kite intersect at a right angle because they are perpendicular. So we reached the end of our lesson. I want to thank you for reviewing with me. Some related videos are geometry and of course assessment practice test questions parts 2 and 3. So I have 2 more videos where I go through questions 21 through 40 and then 41 through 60 of the geometry practice test, as well as algebra and of course. So I have 3 videos on that as well, where I break it up into 20 questions each. If you haven't already, please like, comment, share, and subscribe. And once again, I want to thank you for reviewing with me.